Hello everybody. I wanted to share with you today an actual problem I have during designing a system with multiple variable speed pumps running in parallel. So the client has an existing system which is they have two pumps. They are identical pumps and they are running with an FIC. This is simplified show what they have already, but it's a little bit more than that. But anyways, we have a header, two pumps, and the two pumps are identical and are running at the same speed. We have a bias which compensate for differences in pumps efficiency if one of them is brand new and the other one is an old one. So during this system, we have no problem. We have two identical pumps. So the net results is multiplying the flow rate and keeping the same at the same head. So we shouldn't have any problem if the two pumps are identical. And now the client had added a third pump, and the third pump is not identical. It's a completely different pump. He wants to know how we will control the system. And also I wanted to know where is the operating points will be with different operating scenarios. So we will go with a simple system and we'll see what's happening, and then we will jump from there and do some calculation in an Excel sheet which will show you how I did the calculation. This is a typical pump, one pump, fixed speed. This is the pump curve. This valve represents the system load. So when you open it, close it, as if the system itself moving on the pump, on the system curve, which will be here. When you buy a pump, they will give you this flow chart for the pump capacity versus the head. Of course, there is a lot of things here. You have the power consumption, you have the pump efficiencies, the NPSH, and different pump impellers. The design point is here. So, okay, so we would buy this pump with this characteristic. Now, this is a fixed speed pump. If it is a variable speed pump, the vendor will give you a different set of curves. The curves here is, this is at 1800 RPM up to 1300 RPM, and this is the efficiency, your efficiency. So now if you change the speed of the pump, you know what would be the new flow rate and new head. So we're back to our one single pump. Now changing the system load, change the operating point on the curve. As you can see, change from point to another. If you open this valve, the flow rate increase, the head decrease, and so on. Now, if you have an oversized line and valve, you will be operating in this area. In this area, we assume there is no flow, no flow, and no pressure. There's actually no usable flow and no usable pressure. So at this point, we will say, okay, there is nothing in here. So we only will run our pump on this curve. Now, if you have three pumps, for our illustration, we will add non-return valve. The non-return valve will help us in segregating the three pumps. So if pump one pressure higher than the head, then that means it will deliver. If this pump 2 pressure running at lower speed and the head is lower than the header, the pressure of its pump, discharge pressure is lower than the header pressure, then that means it will not be delivering anything, and this check valve will be closed, and so it's dead head now, this pump. If we have pump 1, pump 2, pump 3, they are different curves. We will see how we will run two pumps at a time in the beginning. So we have two pumps here, different curves. The header we have flow rate and pressure, and each pump has its own pressure and flow rate. Assuming we are measuring the flow rate and the head of the charge of each pump. So pump 1 here, we now close completely the valve, so it's deadhead both of them. So the pressure here will follow the highest pressure of to the two pumps, which is this value. Now you open the valve a little bit, allowing some flow to flow. The pressure is in the range between the deadhead of pump 1 and deadhead of pump 2, so we think that's okay. This pump will only be delivering some fluid. This pump will not deliver anything because the header pressure is higher than the maximum pressure it can develop. Opening the valve a little bit more, so the pressure now is below both deadhead. That means this pump will deliver something as this much, and this pump will deliver that much. So now, what is the net result of pump 1 and pump 2? Between the value of deadhead of 1 and 2, we will follow the same curve of pump 1 because pump 2 is not effective at all, cannot deliver anything. But below this value, we will have to add the value of each flow rate to each other. So at this point, we'll add this much to this much. So now this is pump 1 and 2 new curve. So the red dotted line is our new one single pump equivalent to those two pumps. For variable speed pump, what we will have is one curve at 100% speed, one curve at 50% speed, let's say. How you can find the new value or the new curve? We have simple relation between the flow rate, which is the flow rate divided by flow rate. It is the speeds relation. The head is the square of the speed relation. Meaning if you have 3 pumps, you have a range of operation for pump 1 and pump 2 and pump 3. So the first step is to find for each pump the new curve. So you will find if this is 50%, I need to know where is the new curve of pump 1. This is 70%, I need to know where is the curve. And pump 3. Now add all those 3, give you the white dotted line, which is the equivalent pump curve, pump 1, 2, 3. From the system curve, which is this black, this is from the process guides, will give you this curve. You will find the intersection point, which is your operating point. When you receive the 3 pumps curves from the vendor, you would need to transfer this graph into values to your Excel sheet. So what I do normally is, instead of measuring it with a ruler, I use something like PowerPoint or AutoCAD or something, draw some lines between the reference and the curve and just measure those, stop the lines and put them into an Excel sheet. In this case, I have gallon per minute on this curve X and I have foot in this head. I can take it and convert them into meter cube and meter cube per hour and meter as heads. So now we will go into the Excel sheet to see where we are on the Excel sheet and how we will do it. So here is the Excel sheet, and in this column we enter the gallon per minute. This is the measured line lengths. Then I have some scaling, convert them into meter cube versus meter. And this cell I will put the speed of the pump. So let's say assume it's 100%, so it should be exactly the same speed here. So in these two columns, F and G, we will have the current speed effect on the flow rate and meter cube. So I will have the flow rate and the head on those two columns. How we'll do it, we'll say this is plus this value, which is multiply divided by 100. So that is how we'll do it. Take the flow rate multiplied by the current speed divided by 100 will give you the new flow rate. Of course, it's 0. So assuming this is 50, you will find here I say 90, it's become 45. So it's exactly 50%. So just make sure it's was working right. So if I put 100, everything would be the same. If I put 0, everything should be 0. So now I need to do the head, the current head. So it will be plus the head multiply the speed divided by 100 and to the square. So speed is 0, the head is 0, speed is 100, should be 62. So now double click, just add the formula, copy the formula here. You can see it's exactly the same. If I just make sure that I have all my stuff together, same thing, number is 2, even it's 0 here. So you can see they are exactly the same. So if I put here 50, so now it's 62 becomes 16 because it's the square root. Sorry, the square of the speed difference. Now I need to draw these guys in a curve. Insert XY curve, and here we are. So this is my chart, shows the flow rate at the bottom and the head at the y-axis. If I put 100 as my current speed, so this is my now current pump curve. I can add now the trend line, polynomial, third degree, and display the equation. So I have now, this is the equation of my curve. I put 50. So it's automatically I have the new parameter of my curve. So the relation is between the y, which is the head, x is my flow rate, q. And this is the equation. We have seen now that we can have the trend equation, and this is our trend equation. And here you can see that we have the equations, the formula, which can get you the same parameters, those guys here. Now I put here the formula so you can look at it and see it, and it's give you, this is the y and this is the x. So you define the y and the x, and then it will give you the variables. This is if you have the equation head as a function of the flow rate, or the flow rate as a function of the head. Okay. So if we put this as 100, you find the new equation parameters. 50, exactly the same. So let's jump into our problem now. I have pump 1 pump 2, pump 3. This is the curve from the vendor, the actual pump 100% pump curve data, and this is my speed of this pump 1, and this is the new curve. Similarly, pump 2, pump 3, as we've seen before. So the only thing I added is the data here. Let's say if I put here 100, it just pump in here and calculates the new curve. For pump 1, pump 2, pump 3, exactly the same. And to the right, we have the graph, which will show us pump 1, pump 2, pump 3, pump 1, pump 2, pump 3. This is 100, this is 87, this is 100. So the pump 1 and 2 are identical. So if I put this as 100, we'll find the two curves are, one is behind the second. P1 and P2 exactly the same. Pump 3 is completely different pump here. So now, how we will calculate the net pump or the summation of the three. So let's say here this is 70, this is 75, just to see that we have 3 pumps here, and I did a macro here, a macro which will combine the 3 of them. We will see how the macro works. Okay, so the pump 1 and 2 and 3 is the red dotted line. Okay, so this pump 1 and 2 actually ends here, and pump 3 actually can give you more head, a useful curve head in this area. But anyways, this line is the process system curve, so I can see it's intersect here. So I can find that this is my operating point, if this is my operating speeds of the 3 pumps. The only thing is here, you got a black line here. This black line shows pump 1 and 2 and 3 when the 3 of them are delivering. So the dotted is any one of them is delivering. So if it's only one of them, like say this guy is 100% very far away, and so you run across the pump 1, and then pump 2, let's say this is 80%. So pump 2 is here. So you can see now pump 1, we follow pump 1, and then between those 2 values, you have pump 1 and 2. Now pump 3 comes into effect starting from this point, and the black line is pump 1 and 2 and 3 are operating. So I can know exactly if I'm operating in this point, pump 1 and 2 is delivering, pump 3 is not delivering anything. But if I reduce the first one to 80% and recalculate it, I can see now that I have the 3 pumps are running actually. So by this I can figure out where is my operating point, how each pump are contributing to the flow rate. Now we want to see how is the calculation works here. The first thing before we go into the macro, we have a couple of things. The first one is the head of pump 1 and 2 and 3. This head is now this is my running head, maximum head. Let's color it in red. And so this guy, and this guy. This is the maximum head the pump deliver. This is, I wanted to know which one is the highest. And then I work from each one of them. Remember that I have the equation here, which is give me the flow rate against the head. So if I have any head, assuming the head is 100, I can substituted in this equation, and I can find the flow rate for pump 1, pump 2, pump 3. So I'm using those values. The second thing is I need to know is the maximum flow rate here. So this value and this value and this value. So I need to know the maximum, because below this value I should not have any flow rate. Also, this is my minimum pressure. There is nothing below the 23, 21, 21. So let's go into my macro. See what's there. Okay, so it started by looking at the maximum flow rate of pump 1, 2, and 3, and it's denoted by the cell 45 and 4. 4 and 45 and 4, which is 45 and 4. This is my maximum. Okay, so now I have the minimum pressure, maximum flow, minimum pressure. Then I cleared all the data, selected the data, which is I'm writing to those cells, so I need to select them, range, cells, so and so, then clear this range. Now I need to know which pump deliver the highest pressure, which is A. So A is my highest pressure, so I assume A first, give it to the first pump. Then check with the second pump which one is highest. So now A equal to the highest pressure developed. 4.3, 4.7, 4.11 are the maximum pressures. Four, 3, 4, 7, 4, 11. So I'm comparing those three, taking the highest pressure. Now this is a 4 next loop. I'm using Z as my starting point, which is equal to the highest value of pressure to 0. And then I'll go with only 2 meter difference. And then this is my pump curve fitting. I'm just reading the data now and calculating the flow rate at this pressure. Z is my new pressure, which starts with the highest pressure, and calculating the Q1, Q2, Q3. Now, if you try to calculate the flow rate while you are outside the range of your curve, you will get a negative value. So if the flow rate is more than 0, that means it is good value, but it is below the maximum flow rate, and my pressure is higher than my minimum pressure, then I will consider Q1. Q1 equal Q1. That's nothing. Here you can just ignore it. But if you have any problem with these, like you have the flow rate is negative, or the flow rate from the curve, because the curve doesn't know anything, it just you put numbers and it will give you flow rate. So if I put pressure here as 1 million, so it give me flow rate. It is just an equation. So if the flow rate is higher than the maximum flow rate of this pump, or my assumed pressure is, because in this loop I go up to 0 pressure, then my flow of this pump, flow from this pump is 0. Exactly the same for pump 2 and 3. Now, I take the Q1, Q2, Q3 as my maximum flow getting from, I can get from those pumps at that head. And then I plotted it or draw it in the, write it down in the Excel sheet in those cells. So it will write it down here. So those are the combined pump flow rate and pressures. I use this to draw this curve. So if you look at this curve, I'm taking those data to write it down, to draw this curve. So that's a very simple thing, guys. So when you click on this button, you clear the old data, the whole data in this range, put the new data there. The curve, the chart immediately take the new values and put it there. And you can see it. Now, just to continue with the macro. The new curve, if and only if Q1 and Q2 and Q3 are not equal 0. So this is combining them if only the 3 of them are delivering. In this case, you write it down in somewhere else. I write it down in here, which is the black line. This guy. Okay. So this is everything about it. There is nothing in the macro more than that. It's exactly the same thing, and then you write down, or you just put back in the Excel sheet the values of the X and Y's, which is in this case your head, and this is a combined value. The last one here is just I'm going to select. The reason for this thing is when you click, now I'm running the time, it will go into something like in here. So I wanted to show always this chart. So I'm selecting back to this cell, just selecting the cell. Now if I put here, let's say 95, I'm running 95. Okay, you can see now you have only 2 pumps are operating, not the third pump. So you have to have those 2 pumps running at maximum 80%, and this is at 100%. If this one goes into 80% as well, you can see it's very far below. So I'm only getting the 2 pumps again. So there is a relation between those guys has to be in there. So I have to monitor those 3. If from control point of view now, how you will know where you are operating, there is a couple of things. If you have a flow meter in front of each pump, I don't have. You have, those are a motor operated pumps, so I can measure the current. The current is related to the load on the pump, so I would know those pumps are loaded or not loaded. You can figure out with the current instrument if you have, if each pump is loaded. 100. Of course, I could get those instead of macro. I can do it with the formula on the cell, but on the sheet. But I found that macros is very quick and easy. Anyways, I hope this is useful for you. If you have any problem, just drop me a line or something, and I'll get back to you. Thank you, and see you in a new video.